This is commentary for the functional groups acids and esters. So in these slides we're going to go ahead and talk about naming carboxylic acids, acid salts, which is not shown in this slide, but at least in this slide, but I'll talk about it, and carboxylic acid esters. So to start us off, we're going to go ahead and focus on carboxylic acids. This is the functional group. We call this a carboxyl group, and it's connected to a R, which is a hydrocarbon or hydrocarbon derivative. So some key qualities is it has the carbon is connected to both a carbonyl group and it's connected to a alcohol group at the same time. So that's where they get the name from. So on the carboxylic, the carbo comes from the carbonyl name, and the hydroxy term for alcohols, that's where the oxy comes from. Hence, together it's called carboxylic. And then it's called carboxylic acid. Now, the acid portion of the name comes from the fact that this hydrogen right here on the alcohol, this actually can pop off when you put it into water. So just to go ahead and show you really quick, let's go ahead and bring up ISIS. And let me go to my example right here. So in this case, I'm going to go ahead and highlight this molecule right here, and I'm going to go ahead and pop it into water. When I pop it into water, this hydrogen right here that originally made up the alcohol portion of the carboxyl group is going to go ahead and pop off, and it will basically dissolve into water. In actuality, what happens is the hydrogen will actually combine with the water. So if we take a look at the top picture right here, the hydrogen and the water are going to come together, and they're going to go ahead and form what's called a hydronium ion. And the original carboxylic acid will actually form a negative formed ion. So here I have an original carboxylic, we call it an carboxylic anion now, and then I have the water molecule that actually picked up the hydrogen. Just as soon as the hydrogen pops off in this weak acid, the hydrogen can be put right back on the oxygen. Consequently, if you notice these two arrows, just as soon as you have a forward reaction where the hydrogen comes off, the hydrogen can be put back on in a reverse reaction. So I'll go ahead and I'll highlight in red. So looking at our water, beaker full of water right here, just as soon as it pops off, the hydrogen can literally pop back on. This is why we call it a weak acid. So it's kind of weak-minded, it can't make up its mind. As soon as it pops off, it comes back on. But now this gives you insight into the name carboxylic acid. Going back to our slides, acetic acid is a common name for this particular acid to the left. This is one of the two components found in vinegar. So vinegar is actually made up of acetic acid and water mixed together. Consequently, the carbonyl portion contributes to the really pungent flavoring of vinegar. Let's go to the other one. Here we have a common name called formic acid. In this case right here we have a molecule which is created by ants, for example, and can deliver a very painful sting. So you want to memorize these two common names for these particular molecules, and if you notice underneath in parentheses it actually shows you the UPAC name, which is what we're going to get into right now. So this is how we name it. First thing we do is we notice that just like aldehydes, carboxylic acid functional groups are always at the end. So I'm going to go ahead and I'm going to go ahead and circle the N carbon right here. Consequently, the one is implied. It may be, you may include the one or not. It's up to you. We're going to go ahead and replace the parent name. I'll highlight the parent. In this case, in the lower left-hand corner, if this is propane, we're going to go ahead and drop the E and replace it with a oic acid. Consequently, propane now becomes propanoic acid. Again, the one is optional. You can choose to include it or not. If we look over to the right-hand side, we have an example of 3-bromobutanoic acid. Notice they went ahead and on the N carbon, here if you see a COOH, it's automatically implied to look like the example on the left. That's their quick way of writing it. And you won't see that usually on the exam. Usually I'll actually have it where you can see both the double and single bond. But I want to show you both ways just because sometimes the book likes to use COOH, and that implies to be this expanded form to the left. But going back to naming, let me erase all this. Carbon 1, 2, 3, 4. This is butane, so we replace the ane, the Ne with, or we replace the E with a oic acid, as highlighted here. So in this case, it's going to be butanoic acid. Now, for this class, I'm not going to give you additional functional groups with suffix names. I'll only give you other branches or substituents. Or functional groups that have suffix names. So for example, I could easily give you something like bromine, since that's a suffix name. So in this case, carbon 1, carbon 2, carbon 3, this is 3-bromobutanoic acid. So let's go ahead and practice really quick. So in this case, I could give you something that looks like this right here. CH3, CH2, and then I'll give you the functional group in a expanded form. You don't have to draw the lone pairs, but I always think it's a good habit. So, here we have the carbonyl group right here. And then here we have the alcohol group, and when it's on the same carbon, it's called a carboxyl group. I do want to also point out, and I'll go ahead and use a different color. See this portion right here? I explained to you how we got the name acid, but this is going to be important later on. Based on whether this is a hydrogen or a metal or an R group, the acid portion is going to change. So that'll be important in a few slides down. So in this case, we're on carbon 1, 2, 3. It's an N carbon, so you can include the 1 or you do not have to. The 1 can be implied. The the parent name by itself is propane. However, we're going to go ahead and drop the E and replace it with oic acid. In this case, propanoic acid. What I'm going to do is I'm going to add a I'll go ahead and I'll add a functional group. In this case, I'll go ahead and I'll add in a iodine. So in this case, this would be called a 3-iodopropanoic acid. If I wanted to, I can include another one. I probably should fix this part right here, though. Change it to a CH2. I'm just going to go ahead and cross this out right here. So this is just going to be a CH. And I'll go ahead and I'll change this to a OH. Now, this is where the prefix for the alcohol name comes into play. So in this case, this would be 2-hydroxy. And then you'd have a dash, but I'm out of space. I'll just write a really long dash over here. 3-iodopropanoic acid. What I could always do is I could always, instead of adding in a alcohol, I could add in a ether. So in this case here you have a CH3. So this now slightly changes. So it's no longer a hydroxy. In this case it would be, if there's only one carbon coming off, it would be a methoxy. So, let's go ahead and move on. I think I beat that to death. Is there anything else I should cover on this slide? Oh yes, one last thing. Whenever you have a oic acid, there's always going to be a nice big space in between. So please keep that in mind. You need to have that space in between. If it's put together, it's completely wrong. So you need that space. So let me go ahead and do 2 more, and then we'll go ahead and we'll move on. So let's see. Let me go ahead and give you some line angle structures. So in this case, carbon 1, 2, 3, carbon 4, carbon 5, carbon 6. Notice I do have a branch. This is just a good old-fashioned methyl on carbon 4. This over here is going to be a oic acid. And the parent's going to be a hexane. So in this case, it's going to be a 4-methyl. Hexanoic, make sure you have a big space, acid. Okay, let's go ahead and do one last one. This is one of my favorites. This is one that you should already have memorized. In this case, this is going to be what we cleverly call a benzoic. Oops, forgot my Z. Benzoic acid. Alright. So, moving on, I beat that to death. Here we have benzoic acid as the parent, P for parent. And then these other ones are going to be B for branches. Branches. So we learned in the aromatic chapters that that we can go ahead and have a parent UPAC name, such as phenol, or in this case benzoic acid. Carbon 1 is going to be at the is going to be where the carboxylic acid is. I should point out that it has the highest priority. So just like aldehydes or ketones, all of these suffix functional groups are always going to have the highest priority. It will always be carbon 1. So in this case, we go in the direction of the alkyl groups. So this would be a 3,4-dimethyl benzoic acid. Here we have on the right-hand side 2-hydroxybenzoic acid. The common name, C for common, is salicylic acid because it's from the salix tree. This is a acne treatment medication, and it's pretty cool. If we go ahead and we add an ethanol and what's called esterification, we can create what's called acetylsalicylic acid. So this is an important precursor for making aspirin. Physical properties of carboxylic acids. The bottom line is this. You can have, make sure you write this down on your slides, for a pure substance or a mixture, carboxylic acids have 2 hydrogen bonds. 2 simultaneous hydrogen bonds at a time. Because they occur at the same time, we call these hydrogen bond dimers. So they have more hydrogen bond bang for your buck. Keep in mind, consequently, when it comes to which has stronger intermolecular forces, carboxylic acids have much higher intermolecular forces than alcohols because carboxylic acids can form 2 hydrogen bonds at a time compared to alcohols, which would form 1 hydrogen bond on average at a time. Because you have double the hydrogen bonds, you have stronger intermolecular force. Therefore, carboxylic acids have much higher boiling points. Let me erase all this. They have much higher boiling points than alcohols. So here's a nice picture of one, although they got kind of lazy. So let me just go straight to my ISIS example that I have right over here. Not this one, my other one. There we go. So in this case right here, I'm going to go ahead and highlight. This is a pure substance molecule. Go figure, because you can see it. You can see a duplicate. Let me go ahead and so here what I'm doing is I'm rotating it so that the So here I'm going to bring it in. So the carbonyl oxygen is going to hydrogen bond with the hydrogen on the alcohol oxygen. And voila, they have hydrogen bonding. At the same time, you're going to have hydrogen bonding between this carbonyl oxygen and this alcohol hydrogen. So again, here's a classic example of a hydrogen bond dimer. Now, if I wanted to, I'll just make a duplicate over here. I can go ahead and have a mixture, where in this case one of my favorite mixtures is to use good old-fashioned water. So let me just go ahead and multiply this one right here. So in this case, the hydrogen on the water molecule is going to hydrogen bond with the oxygen. And then, let's see if I can rotate that particular molecule around. Oh, I guess I can't. Oh well. And then the hydrogen on this alcohol oxygen is going to hydrogen bond with the oxygen. So this is a hydrogen bond dimer. So two hydrogen bonds, and they like to form a dimer. Going back to our examples, moving on. Here is an example of what happens when you put carboxylic acid in water, represented by this reaction right here. And as I showed you earlier, the hydrogen highlighted in yellow is going to bond with the water, and it's going to form a hydronium ion, and it leaves over a temporary carboxylate ion. Again, this is what we call a reversible reaction, because as soon as it lets it go, since it's a weak acid, it may immediately change its mind and pick it right back up. So I always think of these as like card sharks, or not card sharks. They're I always think of these as loan shark. Yeah, there you go, loan shark. So as soon as they give away a hydrogen, they expect it right back. So you'll be expected to predict the product, although not sketch. You'll be expected to sketch the product, but not to give the name, since I'm not going to teach you how to name ions. Here's another example right here: benzoic acid. Again, weak acid combines with the water, forming a hydronium and a temporary ion.